Okay, to make sure we're prepared for our test, we're going to run through the major ideas in this unit. Then we're going to start with some review of vocabulary. Then we're going to practice classifying reactions, balancing equations, and finally predicting products of reactions. All right, let's start with this first one. I want you to read it, and I want you to select all that apply. Now you'll see that I put letters down here below each chemical, A, B, C, D, E, and I want you to select all the chemicals that are products. Well, if you said products are on the right side of the arrow, which they are, and chemical C, D, and E were all products, you are correct. On to the next one. Go ahead and read it and then choose your answer. Well, if the chemist had to bring in 2 chemical bottles, that means they brought in 2 reactants, right? The chemist brings in the reactants, and the reactants are on the left side of the arrow. Now you can see in chemicals, or in reactions A and C, there's only one reactant, so those aren't the ones the chemist was doing. They brought in some sodium and sulfur. There you go, they brought in 2 chemicals. B must be the correct answer. Go ahead and read it and then choose your answer. Okay, if lots of bubbles are formed, I think it means they're forming a gas as a product. And you can see right there, this is the only one that has a gas being formed as a product. So the state symbol is what told us that B was the correct answer. Go ahead and read it, and then choose your answer. All right, if we were looking for a reactant, remember we're looking on the left side of the arrows because we have reactants and products, and we're looking for one that has been dissolved in water. Now you remember that does not mean it's liquid. If you dissolve something in water, it's aqueous. So we're looking for something, there it is, the HCl was dissolved in water. Because you remember HCl, it's, a gas when it's pure. If you dissolve it in water, then you would write AQ. The only things that are liquids have to be pure liquids. They can't be dissolved in something, right? Okay, on to the next one. Oh, by the way, so B was the correct answer there. Go ahead and read it and then choose your answer. All right, if we're looking for the arrow here, I think this is reacted with that. I think this probably represents the plus sign. And this must represent the arrow, because then we have our product over here, right? So we have reactant, reactant, product, like that. So to yield, it's a very unusual word. We don't see it all that often, but to yield is a way of saying the arrow. All right, read this one and then choose your answer. All right, if we want to know what the state symbol of sodium metal would be, hopefully we didn't fall for the M thing, right? There's no such thing. The only state symbols are S, G, L, and AQ. That's it. So if something's a metal, obviously metals, powders, right? If it had said powder, all of those things are solid. So A would be the correct answer. All right, we're going to do a little balancing. Now, balancing can take a while, and we're not going to do a ton. I think we're going to do 3 or 4 representing a variety of difficulty levels. So go ahead and write this one on your paper, and then I want you to, we're also practicing this system because we think we probably are going to see this on the test. After you balance each one, you got to balance the whole equation. Then I want you to see what number is going in front of PT there and choose the correct letter. All right, I'm going to show you how I'm going to do it, and I'm not going to think too far ahead because you remember just one element at a time. The PTs are actually balanced. There's one of each. So I'm going to do the sulfurs. If I'm going to have 8 on the left, I'm going to need 4 over here because 4 times 2 is 8. Now I have 4 PTs, so I'm going to put a 4 there, and I think we're balanced. I would put a 1 here, and so therefore PT, the correct answer would be D because 4 was in that slot in front of the bolded one. Let's try another one. Do same thing, write the whole thing on your paper, balance the entire equation, but here you're going to choose your answer choice based on what goes in front of chlorine. Remember, you cannot figure that out without balancing the whole equation. Okay, let's see. Maybe we'll start with chlorines. There's Cl2, Cl2 looks pretty good. Br2, Br2 looks pretty good. Mg, Mg, oh my goodness, is it already balanced? It's already balanced. So 1, 1, 1, and 1. Isn't that so weird? So therefore, what goes in there? A. It was already balanced. Let's try this one. A little bit harder, by the way. The reason I think this one's harder is because O is in two places on one side. You remember those are the harder type. But write it out on paper, balance the whole thing, and then choose your answer based on what goes there. All right, now I have a feeling I'm gonna have to go back and forth. You remember, doing this in pencil on your test is super important, and having your eraser ready is also important. So I'm gonna start with calcium. There's one calcium, looks good. I'm leaving the oxygens to last because they are in more than one place. So I have two H's, but over here I actually have two H's as well, because you can see that outside the parentheses there's a 2. All right, now we got to do O's, and O's can be a little bit tricky. If I were going to say how many O's are on the left, there's actually one right there and one right there. That's 2 oxygens. Keeping track of that, I'm doing oxygens, right? And over here, how many oxygens are there? There's 2. 2 because there's an O, but there's 2 on the parentheses. So there's 2. So the oxygens are already balanced also. Let's see, one calcium, 2 oxygens, 2 H's, 2 H's. Oh my goodness, this one's balanced too, as it is. We don't have to do anything. The correct answer is A. Okay, let's keep going. Let's do another one. Go ahead and balance this equation and then type in what you get right there. All right, I'm going to start with the chlorines. I have 2 chlorines on the left, so I'm going to put 2 chlorines on the right. I have 2 silvers on the right, so I'm going to put 2 there to get 2 silvers. Now I have on the left, I have 2 nitrates. Over here, I only have 1 nitrate, but remember that 2 in front have 2 nitrates, so my nitrates are now balanced as well. So I think we might be balanced. I can put 1s in there, and the correct answer in front of the bolded one was B. All right, let's do a little practicing classifying reactions. So how about this one? And by the way, choose your answer choice. A is synthesis, B is decomposition, C is single replacement, D is double displacement. Remember, replacement, displacement mean the same thing. Or an E is combustion. The correct answer for this one was E, it's combustion. It makes CO2 and water, and a hydrocarbon burns with oxygen. It's definitely combustion. Let's try another one. What about this one? This one's a little bit tricky. It's definitely not combustion. It's not synthesis, right? You don't have two things coming together. I think it's a displacement reaction. It's just subtle and weird. You see the CR seems to be picking up like an OH in here, and then H is going with SB. I think it's double displacement. So D is the correct answer. Let's keep going. Next one. Choose your answer. This one has 2 things coming together to make one. It's definitely A, synthesis. Let's try another one. Go ahead and choose your answer on this one. This one's definitely double displacement. You can see ammonium and iron. You write them down first, and then they swapped their partners. Definitely double displacement. So D is the correct answer. Forgot to say that. Let's try this one. 2 things coming together to make one. It's definitely synthesis. Let's try this one. 1 thing splitting apart into 2. It's definitely decomposition. Try this one. Here, it looks to me like the couple's coming to the dance. There's the single person. That one steals oxygen as a date, and aluminum goes home alone. That's so sad. That is clearly a sign of single replacement. C. Let's try this one. I think this one is definitely E. It's definitely combustion. Makes CO2, makes water, burns an oxygen, and there's a hydrocarbon. All the signs of a combustion reaction. Let's try this one. This one is double displacement, because you can see H goes with O, Al goes with Br. They clearly are swapping partners. It is a double displacement. And let's try this one. This might be our last one. 1 thing falling apart into 2 things. It's decomposition. B. All right, we're going to do a little practicing of writing predicting products. You can see there's a variety of choices here. I think we've got a single displacement here. We've got a double displacement, and that one's a synthesis down there. So what I want you to do is we're just going to do one at a time here. So I want you, for number 1, I want you to write the whole reaction, not just the products. Write the whole reaction. And when I say be sure to write neutral formulas, what I mean is check charges and check for diatomic elements. Okay, this first one is one of the trickiest ones out there because you got to decide which atom chlorine goes with. Chlorine and bromine will not get together. They're both negative, right? If you look them up on a periodic table, they're both negative. Chlorine's going to get together with Mg, and Mg is going to go first because Mg is +2. This is -1. Remember, the cation goes first, and when I check charges, I need 2 chlorines. And it would be nice if I erased my charges at the end. Let's see, and that ends up bromine being by itself. Now, we checked charges on the compound. We have to check to see if bromine's diatomic. It is diatomic because it is a Brinkelhoff element. And there we go. Notice it says you do not need to balance them. You want to read the directions, but since it said not to balance them, I'm not going to worry about it. All right, let's keep going. Let's do another one. I want you to do number 2 right now. Whole reaction written out. Don't forget to check charges. Okay, this is a double displacement, so you know how I feel about these. I write down the 2 cations first, right? Spread them out by a lot. Now let's swap their anions. I get F here, and here I get NO3. I'm not bringing the 2 because that was part of checking charges, but I am bringing the 3 because it's part of the nitrate. Then I am going to check charges because these are compounds. +2, -1. We're going to have a 2 there. And this one's +1, -1. We don't have to do anything to that one. And then when we're done, come in and erase those charges. All right, we're doing pretty good here. Let's choose a different color marker. Let's go with purple. All right, number 3. I want you to type in the whole reaction right now. Okay, did you check charges? So I'm going to write down, I think it's double displacement again, so I'm going to write down the 2 cations spread out, and then I'm going to switch their partners. So this is Cl, and this is SO4. The 4 was part of sulfate, so I've got to keep it. Oh, wait a minute. I did badness. Let me go back. I did not swap their partners. What's wrong with me? Okay, let me see. This gets SO4. There we go. And this gets Cl. All right, now we need to check charges. +2. Oh, nope, not +2. +1, because that's on the periodic table, right? This one, sulfate, I had to go to the polyatomic ion chart. It was -2. And so therefore, I'm going to need 2 sodium, so I'm going to put a 2 down there. Calcium from the periodic table is in the second column, so it's +2. Chlorine is -1 from the periodic table. And yep, I'm going to need 2 chlorides, so boom, there I go. And then I erase my charges at the end. All right, last one, I want you to do number 4. Do the whole reaction and check charges, check for diatomic elements. So we're going to put them together, and remember the SR is going to go first because it's the positive ion. I'm leaving off the 2 because I'm going to check charges. SR is +2 according to the periodic table, N is -3. So it's going to take 3 strontiums. If I write down 3 strontiums, it'll get a +6 total charge, and therefore it's going to take 2 nitrogens to get to a -6 total charge. And then when I'm done, I erase my charges. So yep, leaving those subscripts super important. All right, very good. Now one last problem to finish things up for today for our balancing. In this one, this is kind of an interesting type of problem here. And let me switch back to another marker. So they're giving us this description, right? You notice they're giving us the reactants and the products. They're giving us everything. Now these kind of problems where they give you all of the reactants and products are really about writing names and converting names to formulas correctly. In other words, when you write magnesium hydroxide here in this spot right there, you got to check charges, right? When you write cesium chloride in this spot, you got to check charges. Now the other thing I want you to do, other than to type in all of the reactants and all of the products with charges checked, they want state symbols, right, for each one of these. Now you notice if you read the description, it'll give you hints to what the state symbol is. So type all of that in right now. Okay, so if I'm doing magnesium hydroxide, hydroxide is a polyatomic ion. It's not just H, right? And Mg is +2, OH is -1. I clearly am going to need 2 OHs, but because it's a polyatomic ion, I got to put it in parentheses. Don't forget to put it in parentheses. Then I go to cesium chloride. And I got to check charges because it's a compound again. That's +1, that's -1. It looks fantastic. And then let's do the products while we're checking charges. I've got magnesium chloride. That's +2, that's -1. So I'm going to need 2 chlorides. And then lastly, cesium hydroxide. This is +1. My polyatomic ion chart says that's -1. So we don't need anything there either. Now you remember, good chemists always erase their charges at the end because charges mean something, and since we made the compound neutral, we're not going to have any charges anymore. All right, so we're doing pretty good. Now, let's also do the state symbols while we're here. Let's see, magnesium hydroxide, it says aqueous. Remember, that's something dissolved in water. Sometimes it'll say solution, right? If it says solution, you know it's also aqueous. Is added to a solution. Yep, there it is. That's aqueous. Of cesium chloride to yield. Remember, that's the arrow. Aqueous magnesium chloride. Oh, that's aqueous too. They just told us that. A lot of stuff dissolved in water. And solid cesium hydroxide. By the way, this isn't a very good problem because cesium hydroxide would not really be a solid. But we'll take their word for it and we'll use it as it is. And that's it. That's how we do those last type of problems. So there's our review. Always reach out if you have questions. Get your questions answered before the test, and we'll see you on test day.